Start at the very beginning. What exactly are quantum dots? Imagine particles so tiny that they're measured in nanometers, which is a billionth of a meter. Quantum dots are semiconductor nanocrystals, and their size is what makes them so special. When you shrink materials down to the nanoscale, their properties change in fascinating ways. Quantum dots can absorb and emit light in vivid colors, and this ability is at the heart of their many applications. In this video, we'll explore how quantum dots work, why they're so unique, and how they're shaping the future of technology. Quantum dots are incredibly small, so small in fact that their size directly influences their behavior. At the nanoscale, the rules of quantum mechanics take over, and this is where things get interesting. Unlike larger materials, quantum dots can confine electrons in all three spatial dimensions. This quantum confinement leads to discrete energy levels, much like the rungs on a ladder. The result, quantum dots can emit specific colors of light depending on their size. Smaller dots glow blue, while larger ones shine red. This size-dependent color emission is a hallmark of quantum dots and a key reason for their versatility. So how do quantum dots actually emit light? When energy such as light or electricity is applied to a quantum dot, it excites the electrons inside. These excited electrons jump to a higher energy level. When they return to their original state, they release energy in the form of light. The color of this light depends on the size of the quantum dot. This process is known as photoluminescence. Because scientists can precisely control the size of quantum dots during their synthesis, they can also control the color of light emitted, making quantum dots incredibly useful for a range of applications. One of the most striking features of quantum dots is their ability to emit a wide spectrum of colors. By simply changing the size of the quantum dot, scientists can tune the color from deep red to bright blue and everything in between. This tunability is not just visually stunning, it's also incredibly practical. For example, in display technology, quantum dots are used to create screens with richer, more vibrant colors than ever before. This property also makes them valuable in scientific imaging, where precise color control is essential. Quantum dots have revolutionized the world of display technology. In modern televisions and monitors, quantum dots are used to enhance color accuracy and brightness. These tiny particles are embedded in a film inside the screen, where they convert blue LED light into pure, vibrant reds and greens. The result is a display with a wider color gamut and greater energy efficiency. This technology, often marketed as QLED, has quickly become a standard in high-end displays, offering viewers a more immersive and lifelike visual experience. Beyond displays, quantum dots are also making waves in the world of lighting. Quantum dot-based LEDs or QLEDs offer several advantages over traditional lighting technologies. They can produce pure tunable colors with high efficiency, leading to more natural and customizable lighting solutions. These lights are not only energy-saving but also have the potential to be used in specialized applications, such as horticultural lighting, where specific wavelengths can promote plant growth. As research continues, we can expect quantum dots to play an even bigger role in the lighting industry. Quantum dots are also being explored as a promising material for next-generation solar cells. Their ability to absorb and convert sunlight into electricity can be fine-tuned by adjusting their size and composition. This means quantum dot solar cells could potentially capture a broader spectrum of sunlight, increasing their efficiency compared to traditional silicon-based cells. Researchers are working to overcome challenges like stability and scalability, but the potential for more affordable and efficient solar energy is driving rapid innovation in this field. Quantum dots are making a significant impact in the field of medical imaging. Their bright, stable, and tunable fluorescence makes them ideal for labeling and tracking biological molecules in cells and tissues. Unlike traditional dyes, quantum dots don't fade quickly, allowing for longer observation times. This property is especially valuable in cancer research and diagnostics, where precise imaging can lead to earlier detection and better treatment outcome. As technology advances, quantum dots could pave the way for more accurate and less invasive medical diagnostics. In biological research, quantum dots are used as powerful tools for studying cells and molecules. Their unique optical properties allow scientists to track multiple biological processes simultaneously by using quantum dots of different colors. This multiplexing capability is a game-changer for experiments that require monitoring several targets at once. Quantum dots are also less toxic and more stable than many traditional fluorescent markers, making them a safer and more reliable choice for sensitive biological studies. Quantum dots are also being integrated into advanced sensors for detecting chemicals, gases, and even biological agents. Their sensitivity to changes in their environment makes them excellent for use in environmental monitoring and security applications. For example, quantum dot-based sensors can detect toxins in water or air at extremely low concentrations. This high sensitivity, combined with their ability to be engineered for specific targets, opens up new possibilities for safer and more effective monitoring systems. The process of making quantum dots is both an art and a science. Typically, quantum dots are synthesized using chemical reactions that carefully control their size and composition. The most common method involves mixing precursor chemicals in a solution at high temperatures, allowing nanocrystals to form. By adjusting the reaction time and temperature, scientists can fine-tune the size of the quantum dots and therefore their color. This precise control is crucial for producing quantum dots with consistent and predictable properties for various applications. Quantum dots can be made from a variety of materials, each with its own advantages. The most common types are made from compounds like cadmium selenide or indium phosphide. However, researchers are also developing quantum dots from less toxic materials to make them safe for use in medical and consumer products. The choice of material affects not only the color and brightness of the quantum dots, but also their stability and potential application. As the field advances, new materials are expanding the possibilities for quantum dot technology. Key concept behind quantum dots is quantum confinement. When a material is reduced to the nanoscale, the movement of electrons is restricted or confined in all directions. This confinement leads to discrete energy levels, which is why quantum dots can emit specific colors of light. The smaller the quantum dot, the greater the energy difference between levels, resulting in bluer light. Larger dots have smaller energy gaps, emitting redder light. Understanding quantum confinement is essential to grasping why quantum dots behave so differently from bulk materials. Surface of a quantum dot plays a critical role in its behavior. Because quantum dots have a high surface-to-volume ratio, their surface chemistry can greatly influence their optical and electronic properties. Scientists often coat quantum dots with special molecules, called ligands, to stabilize them and improve their performance. These coatings can also make quantum dots compatible with different environments, such as water for biological applications or polymers for electronics. Surface chemistry is a vital area of research for optimizing quantum dot performance. Quantum dots offer several advantages over traditional materials used in electronics and optics. Their tunable optical properties, high brightness, and stability make them superior in many applications. For example, in display technology, quantum dots can produce more vivid and accurate colors than conventional phosphors. In solar cells, their ability to absorb a wider range of sunlight can lead to higher efficiency. These benefits are driving the rapid adoption of quantum dots in a variety of industries. As with any new technology, it's important to consider the environmental impact of quantum dots. Some quantum dots contain heavy metals like cadmium, which can be toxic if not handled properly. Researchers are actively developing safer, more environmentally friendly alternatives such as cadmium-free quantum dots. Additionally, recycling and proper disposal methods are being explored to minimize any potential risks. The goal is to harness the benefits of quantum dots while ensuring they are safe for people and the planet. You might be surprised to learn that quantum dots are already part of your daily life. If you own a modern television or smartphone with a vibrant display, there's a good chance it uses quantum dot technology. These tiny particles are also found in some LED lighting products and are being tested in new types of solar panels. As research progresses, we can expect quantum dots to become even more common in consumer electronics, lighting, and renewable energy solutions. Despite their many advantages, quantum dots face several challenges before they can reach their full potential. Issues like toxicity, long-term stability, and large-scale manufacturing need to be addressed. Researchers are working on developing new materials and production methods to overcome these hurdles. Additionally, regulatory standards are being established to ensure the safe use of quantum dots in consumer products and medical applications. Overcoming these challenges will be key to unlocking the next wave of quantum dot innovation. Looking ahead, the future of quantum dots is incredibly bright. As scientists continue to refine their properties and develop new applications, we can expect to see quantum dots in even more areas of technology and medicine. From flexible displays in wearable electronics to advanced medical diagnostics and renewable energy, the possibilities are nearly endless. With ongoing research and innovation, quantum dots are poised to become a cornerstone of next-generation technology. Quantum dots are also being explored as building blocks for quantum computing. Their ability to confine and manipulate single electrons makes them promising candidates for quantum bits or qubits. These qubits can store and process information in ways that classical bits cannot, potentially leading to computers that are exponentially more powerful than today's machines. While there are still many technical challenges to overcome, quantum dots could play a key role in the development of practical quantum computers. Photodetectors are devices that sense light, and quantum dots are making them more sensitive and versatile. By tuning the size and composition of quantum dots, scientists can create photodetectors that respond to specific wavelengths of light, from ultraviolet to infrared. This capability is valuable in applications like night vision, medical imaging, and environmental monitoring. Quantum dot photodetectors are also more compact and energy efficient than traditional devices, opening up new possibilities for portable and wearable sensors. Quantum dots are also being used to create new types of lasers. These quantum dot lasers can emit light at precise wavelengths, making them ideal for applications in telecommunications, data storage, and medical devices. Because quantum dots can be engineered to emit different colors, they offer greater flexibility than traditional laser materials. Quantum dot lasers are also more stable and efficient, which could lead to faster and more reliable communication networks in the future. Biotechnology, quantum dots are being used to develop new diagnostic tools and therapies. Their bright, stable fluorescence allows for highly sensitive detection of biomolecules, making them valuable in early disease detection and personalized medicine. Quantum dots can also be engineered to target specific cells or tissues, enabling more precise drug delivery. As research continues, quantum dots could revolutionize the way we diagnose and treat a wide range of diseases. Quantum dots are finding their way into security and anti-counterfeiting technologies. Their unique optical signatures can be used to create invisible inks and markers that are difficult to replicate. These features are valuable for protecting currency documents and high-value products from forgery. Quantum dot-based security features can be easily verified with specialized equipment, adding an extra layer of protection in a world where counterfeiting is a growing concern. Artists and designers are beginning to experiment with quantum dots to create new visual effects. Because quantum dots can emit pure, vivid colors, they offer exciting possibilities for digital art, lighting installations, and even fashion. Imagine clothing that changes color under different lighting, or interactive artworks that respond to your presence. As quantum dot technology becomes more accessible, we may see a new wave of creativity inspired by these tiny, colorful particles. Quantum dots are also making their way into educational tools and demonstrations. Their striking optical properties make them ideal for teaching concepts in physics, chemistry, and nanotechnology. Educators use quantum dots to visually demonstrate principles like quantum confinement and fluorescence, helping students grasp complex ideas through hands-on experiments. As more schools and universities incorporate nanotechnology into their curricula, quantum dots will play an increasingly important role in science education. Environmental scientists are using quantum dots to develop new tools for monitoring pollution and tracking environmental changes. Quantum dot-based sensors can detect trace amounts of pollutants in water, air, and soil with high sensitivity. Their ability to be engineered for specific targets makes them ideal for monitoring a wide range of environmental hazards. As concerns about pollution and climate change grow, quantum dots could become essential tools for protecting our planet. Quantum dots are being explored for use in agriculture, where they can help monitor plant health and optimize crop yields. By tagging nutrients or pesticides with quantum dots, farmers can track their movement and effectiveness in real time. Quantum dot-based sensors can also detect plant diseases early, allowing for timely intervention. These innovations have the potential to make farming more efficient, sustainable, and productive. Food safety is another area where quantum dots are making a difference. Their ability to bind to specific bacteria or toxins allows for rapid and accurate detection of contaminants in food products. Quantum dot-based sensors can be used in food processing plants to monitor safety in real time, reducing the risk of outbreaks and recalls. As the technology matures, quantum dots could help ensure that the food we eat is safer and healthier. Cosmetics industry is beginning to explore the use of quantum dots for new types of makeup and skincare products. Quantum dots can be engineered to reflect or emit specific colors, creating unique visual effects in cosmetics. They can also be used in sunscreens to enhance UV protection. As with other applications, safety is a top priority, and researchers are working to ensure that quantum dots used in cosmetics are non-toxic and safe for skin contact. Quantum dots are being incorporated into textiles to create fabrics with new properties. For example, clothing embedded with quantum dots can change color in response to light or temperature, offering both aesthetic and functional benefits. These smart textiles could be used in fashion, sportswear, or even medical garments that monitor health indicators. As the technology develops, quantum dot textiles could become a staple in the clothing industry. Quantum dots are being investigated for use in next-generation batteries. Their unique electronic properties could help improve the efficiency and capacity of energy storage devices. For example, quantum dots can be used in electrodes to enhance charge and discharge rates. This could lead to batteries that last longer, charge faster, and perform better in extreme conditions. As energy storage becomes increasingly important, quantum dots may play a key role in powering the devices of the future. Data storage technologies are also benefiting from quantum dot research. Quantum dots can be used to create high-density memory devices that store more information in smaller spaces. Their ability to switch between different electronic states makes them ideal for use in advanced memory chips. As our need for data storage grows, quantum dot-based solutions could help meet the demand for faster, more reliable, and more compact storage devices. Optoelectronics is a field that combines optics and electronics, and quantum dots are at the forefront of innovation here. Their tunable optical properties make them ideal for use in devices like photodetectors, LEDs, and solar cells. Quantum dots can improve the performance and efficiency of these devices, enabling new applications in communications, imaging, and renewable energy. As optoelectronic technology advances, quantum dots will continue to play a central role. Photovoltaics, or solar energy conversion, is another area where quantum dots are making a difference. Their ability to absorb different wavelengths of sunlight can increase the efficiency of solar panels. Quantum dot-based solar cells are lightweight, flexible, and potentially cheaper to produce than traditional silicon cells. As the world shifts toward renewable energy, quantum dots could help make solar power more accessible and affordable for everyone. Quantum dots can be engineered to absorb and emit infrared light, opening up new possibilities in night vision, thermal imaging, and telecommunications. Infrared quantum dots are used in cameras and sensors that operate in low-light conditions, making them valuable for security and surveillance. Their ability to detect heat signatures also has applications in medical diagnostics and industrial monitoring. As infrared technology advances, quantum dots will play an increasingly important role. Telecommunications networks rely on the transmission of light signals, and quantum dots are helping to improve the speed and reliability of these systems. Quantum dot lasers and amplifiers can transmit data over long distances with minimal loss. Their ability to emit light at specific wavelengths makes them ideal for use in fiber optic networks. As demand for faster internet and more data grows, quantum dots will be key to building the networks of the future. Wearable technology is another area where quantum dots are making an impact. Their small size and tunable properties make them ideal for use in smartwatches, fitness trackers, and health monitors. Quantum dots can be used in flexible displays, sensors, and even clothing that tracks vital signs. As wearable tech becomes more advanced, quantum dots will help enable new features and improve performance. Automotive industry is exploring quantum dots for use in advanced lighting, displays, and sensors. Quantum dot headlights can produce brighter, more efficient light, improving visibility and safety. In-car displays with quantum dot technology offer better color accuracy and clarity. Quantum dot sensors can also be used in autonomous vehicles for enhanced environmental awareness. As cars become smarter and more connected, quantum dots will play a growing role in automotive innovation. Space exploration is another frontier for quantum dots. Their lightweight and efficient properties make them ideal for use in space-based solar panels, sensors, and imaging devices. Quantum dots can help capture more sunlight for power generation and improve the sensitivity of instruments used to study distant planets and stars. As humanity ventures further into space, quantum dots could become essential components of spacecraft and satellite. Counterfeiting is a major problem worldwide, and quantum dots offer a new solution. Their unique optical properties can be used to create security features that are nearly impossible to replicate. Quantum dot-based inks and coatings can be applied to currency, documents, and products to verify authenticity. These features can be detected with specialized readers, providing a powerful tool in the fight against fraud. Smart windows that can change their transparency or color in response to light are being developed using quantum dots. These windows can help regulate indoor temperatures, reduce energy consumption, and provide privacy on demand. Quantum dots allow for precise control over the optical properties of the glass, making smart windows more effective and versatile. As buildings become smarter and more energy efficient, quantum dots will play a key role in sustainable architecture. Flexible electronics are an exciting area of research, and quantum dots are helping to make them a reality. Their small size and tunable properties make them ideal for use in bendable displays, sensors, and circuits. Quantum dot-based devices can be integrated into wearable tech, rollable screens, and even electronic skin. As the demand for flexible and portable electronics grows, quantum dots will be at the forefront of innovation. Energy harvesting is the process of capturing and storing energy from the environment, and quantum dots are making this more efficient. Quantum dot-based devices can convert light, heat, or even mechanical vibrations into usable electricity. These technologies have applications in powering remote sensors, wearable devices, and other low-power electronics. As the world seeks sustainable energy solutions, quantum dots will play a growing role in energy harvesting technology. Quantum dots are truly remarkable materials, offering a world of possibilities across science, technology, and everyday life. From vibrant displays and efficient solar cells to advanced medical diagnostics and environmental monitoring, their impact is already being felt. As research continues and new applications emerge, quantum dots are set to revolutionize multiple industries. Their unique properties, versatility, and potential for innovation make them one of the most exciting developments in modern science. The quantum dot revolution is just beginning, and the future looks brighter than ever.